chapter 2, but I'm diving into it, 2.3. I don't like the order the textbook goes in. They start off with hard stuff, and then they go back to this easy stuff, and then they go back to hard stuff. I'd rather start you off nice and easy, and work our way to the nasty stuff. Chapter 1, if you put your mind to it and you practice it enough, you should be able to do really well. If you don't practice it enough, I tell you right off the bat, you're going to fail the test. And it's as simple as that. If you practice it, you'll know it, and you'll be able to do it. If you don't practice it, you don't know it, and you won't be able to do it. The review for the test, let me get that out while I'm thinking about it, is this sucker. It's got the answers on the last page. Hopefully they're all correct this time. I think I fixed that one.
How many word problems at the same time?
I don't know, I haven't designed it yet. But it's definitely going to have 3 at least, if not more. I'm telling you, I want you to know these word problems. And I pretty much gave you all the word problems I possibly could put on the test, so you should have no options of not knowing what you're doing. So that's the review. It's 31 questions. I'll answer anything off of this and a little extra homework that I'm going to give you in a little bit at the end of class for Wednesday, and then on the test on Monday, it starts right at the beginning. Goes for an hour and 15 minutes, go on break, come back, and I start teaching to 4. Now, chapter 2, I mix it up, so it's a little bit of, I do all of 2.3, I do all of 2.4, I think most of it. Then I back up and do 2.1 and 2.2 and cover one thing at the very, very end, which is the graphs and how to read a graph. But I like starting with 2.3 because most of you are semi-comfortable with it. Hopefully you're really good at it, because then I can go through it a little quicker. So lines and their graphs, that's all this is going to be about. And you should know everything about lines and graphs. So if we're talking about a line, what makes a line a line? What are its properties? Geometrically. Remember geometry? What made a line a line? Great, it goes on forever in both directions, but so do curves. So what makes a line different than a curve? There's no such thing as straight. So what does it mean to be straight? I swear.
One of the coordinates got to be 0, right?
Nah, doesn't
It's
matter.
like 1x for every line or whatever.
That's something else. We'll talk about that when we go back to 2.1. No. No. What makes a line a line? How would you define a line?
It's straight.
I know, but if you were going to draw one, what would you do?
The arrow.
I'm scared to answer.
That's a good answer. I'll give it to you. A line is defined by this. 2 points. It's straight because between these 2 points, a line is... I'll give you a hint. This can't be a line. We haven't talked about slope, so I really can't say much about slope. Is that a line? That's a curve. A line is different. A line is going to look like this.
Oh, it's the shortest distance between the 2 points.
Thank you. That's what makes it straight. So a line is the shortest distance between 2 points. It's actually a property of a line, but I'm going to use it to define it because most people understand what it means to be shortest distance. If you took the green path, it would take you longer to go from point A to point B. But if you took the blue curve, which is a straight line, it would be the shortest distance. It would be the quickest way of getting there if you did a constant velocity. All right, so we're going to define a line with 2 points. Now, that other word that you use, slope, comes into play, but I like defining what slope is. So let's talk about slope. And the slope, if we look at it coordinately, is the relationship between the line and those 2 points. How do we force those 2 points to be on the same line given a certain slope? Well, When you're talking about graphs, there's really only two motions. You can't travel a graph coordinately on this diagonal. Graphs are either left-right or they're up-down. That's the only options you have. So if we're going to go left-right, we're going to go that way, right through that first point, x-axis, parallel to the x-axis, and we're going to go vertically through this point. What that does is it sets up a nice little right triangle, right here. So we can define slope using these two numbers, the distance of the base and the distance of the height of this triangle. Labeling them is going to get a little strange, so let me go through it. If this coordinate here is 1, 2, let's say that's 1, 2, and this coordinate over here is, say, 7, 4. Sounds reasonable, right? 7 to the right, 4 up, and 1 to the right, and 2 up. Then how far did you travel along the base here? How would you find that out? Well, think of your x-coordinates. What's your x-coordinate directly below that first point? 1. X-coordinate is the first one. Y-coordinate is the second one. What's the x-coordinate directly below this one? 7. So the distance that you traveled going left to right is 7 minus 1. It would be 6. You would start at 1 and end at 7, so that would be 6 units. So I'm going to write it as 7 minus 1. So far, so good. Better known as 6, but I want to leave it as 7 minus 1. All right, once you get to this point, how far did you travel up? You start at 2, and you work your way up to 4, so you went 4 minus 2. Better known as just plain old 2. All right, so notationally, well, number-wise, this is 6 and this is 2. Notationally, though, this is a x-coordinate minus another x-coordinate. We're going to call that this weird symbolism. It's a Greek letter, delta. The triangle is read delta. And it reads change. Now, when you go to a grocery store and you buy a $1 candy bar and you have $5 and you give them the $5, they give you change. How do they figure it out? You gave them 5, you would subtract. So when you see the word change, it means subtract. So when I say change in x, you're going to take your x-coordinates and subtract them. This one over here is going to be known as change in y. Because when we did this one, we took the y-coordinates and we found their change, their subtraction. All right, so slope, we're going to create it as a ratio. A ratio is a fraction, if you want to think of it that way. It's the value of the x compared to the value of the y. So 2 ways of looking at it. We can think of it this way, as a ratio, or we can think of it this way, as a ratio. But only one of them is the slope that we need to think about. So if we do change in x over change in y, what's the change in x in our picture here? Change in x. 6. It's over here. Over 2, better known as, well, 3, right? Over here, change in y would have been 2, and change in x would have been 6, so this would be 1/3. Now we got to talk about realisticness. Is the slope of this line, if you think about it, is traveling out 6 units and going up 2 units. Do you think the slope of this line is very steep or kind of not so steep? Could you ride your bike up it? Could you walk up it? Steep would be you need a rope. So which number better describes not so steep? 3 or 1/3? Which one would you think better describes not so steep? 1/3. It's smaller. It's got a smaller value to it. Plus, if you think about it, for every upward motion of 1, you're moving 3 feet forward. So this better describes basically what's going on with this thing. 3, you would think it would be going a little bit more steep. It has that connotation that's getting larger. So change in y over change in x is the best way to represent slope. So when I write slope, you do this. Slope is equal to the change in y over the change in x. The nice thing about this notation compared to rise over run or any funny things like that is it tells you what variable you're subtracting for the top and it tells you what variable you're subtracting for the bottom. Most people, when they do slope wrong, they do change in x over change in y. Because they're thinking x comes first and y comes second, like a coordinate. With slope, it's totally backwards. Y is coming on the top and x is going the bottom. All right. Not that hard, right? This is nice and easy stuff. So, for example, find slope between the a coordinate -3, 5 and a b coordinate 4, -7. Yeah. So, how do you find the slope between a and b, or the slope of the line segment a and b?
Subtract b from a.
So you say change in y over change in x is equal to, what would you put up top?
-7 minus 5.
-7 minus 5 over
4 minus -3.
4 minus -3. As long as you get your y's in the right places and your x's in the right places, and as long as you go in order, I would do it the other way, but he went this way, right to left. I always go 5 minus a -7, -3 minus 4. I like going the way you read. Does it matter? Make
I
sure.
was gonna ask.
Right, well, let's kind of prove it. Ready? A minus B over C minus D, is that the same thing as B minus A over D minus C? That's the question.
Yeah.
Why?
The sign will change anyway.
Well, what happens when you change the order of subtraction? Like 5 minus 2 is 3, and 2 minus 5 is -3. So if you flip over subtraction, all you're doing is changing the sign. Well, if I took A minus B and made it B minus A, that would be negative B minus A. We changed the sign. But I did the same thing to C minus D and made it D minus C, so that would also be negative. But a negative over a negative is a, so it doesn't change a thing. So it keeps the answer exactly the same. So whether you want to go left to right or right to left is irrelevant. Most people that go backwards do the y2 minus y1 over x2 minus x1. And I always found that confusing. Why go to the second one and back to the first one? I like going in order. It keeps my brain straighter. But either way, you'll get the same answer. Change in y over change in x is equal to -12 over 7. So the slope of this line is -12 sevenths. What the heck does that mean? It means this. If this is the point A, to get to the point B, let's say B is, well it is. To get to the point B, you're going to go down 12. That's your change in y. Y is always going up and down. And you're going to go right 7. And this coordinate down here will be B. Which is kind of cool. So it forms a nice straight line between those 2 points. So that's what slope is. It's change in y, which is vertical, and change in x, which is horizontal. So it's a vertical motion then matched up with a horizontal motion. So about that. No. I meant to hand out. I got
plenty of.
I got 200 sheets of it. I just got to get it. It's sitting on my desk. But this shouldn't require graph paper. Just careful drawing. So I need to graph y-axis, x-axis, hopefully they're at right angles. Technically, the x and the y-axis are just number lines. So you have the x number line and the y number line. You just position them so that one's horizontal and the other one is vertical. We're going to need to plot some points, so I have to be careful with my markings. I want to make sure they're equidistant from each other. If they're not, the graph might get distorted just a little bit. This is where graph paper comes in handy. That should work. 5 by 5. All right, how do I graph this line? Where do I start? Do you start with the slope or the point? The point. A slope by itself means absolutely nothing. For instance, this slope here is -12/7. Well, how many lines have a slope of -12/7? Well, this one for sure, then it goes through A and B. But this one would also have a slope of -12/7, and this one would have a slope of -12/7, and this one. How many could I draw? When you say a lot in math, you say infinite. So there's an infinite number of lines that have that slope, but once you fix one or the other point, it becomes one unique line. So to make this a unique line, -3 is not going to cut it. There's infinite number of lines that have a slope of -3. So where do I start? The point -3, too. So you start here. So when you're graphing a line, the first thing you have to deal with is you need a location, a point. From the point, you can run a slope, but you can't run a slope to a point. So you start at -3, +2, which is right about here. Let's call this A, just so I can label it in the graph. So that's my starting point. From this point, I want to do a slope of -3. Well, slope is change in y over change in x. But I only see one number. You really want to write it as a fraction. So how do I write it? Well, -3 over 1. So that tells you your change in y is down 3, and your change in x, which is horizontal, is right or left, is +1. So your change in y from this point has to go down 3. Well, if I go down 3, where do I end up? Along the y-axis, at least. -1. So it's going to be -1 on the y-axis, but we haven't plotted the point. We're just down -1 below the x-axis. The next number is +1, so which way do I have to go? Right, 1. That's when you plot a point. You got to do both motions to plot a point, not one motion and plot a point. So it's down 3, right 1. Down 3, right 1. Now, that you can graph a line through, except for one problem. What if you did the slope wrong? You would never know, because given any 2 points, there is a line. It might not be the right line, but there definitely is a line. So I highly suggest you either A, continue on the pattern, come up with another one down, or go backwards. Well, if we go backwards, instead of going down 3, you would go up 3, so now we're up at 5. And then where? And then left 1. These points should line up rather nicely. And has a very steep slope. Now, once you graph a line, you really should do this. I wish people would do this, but they don't generally. They graph the line and they go on to the next question. They think, oh, this is an easy problem. I'll just blow through it and get the line and go on to the next question. You have to remember a few things. If you plot your points wrong, your line is wrong. So at least one simple check. What kind of slope does this line have without looking at the number? If this was stock prices, what would be going on with my stock prices? Would they be going up or going down? They'd be going down. So this is negative slope. If it doesn't match up with your slope number, I've had people draw a negative slope and have a positive slope number. And it drives me crazy. This is a negative slope line, so it better represent a negative number. So make sure they at least match up sign-wise, if not quantity-wise. 3 is a relatively large number, so the slope is relatively steep. I would not be able to ride a bike up this hill, going that direction. This direction would be really fun because you'd be flying if you move left or right. Okay, that's it. That's how you graph a line. Isn't that exciting? So what else can we do with this stuff? Well, we can talk about slope-intercept form. It is one of the more common forms of a line. It's generally how I want you to write the equation. Sadly, the book wants you to write your answers this way. AX plus BY is equal to C, where A, B, and C have to be whole numbers, or integers. They have to be integers, no fractions. This is called the general form of a line. The problem with the general form of a line is you can't tell what its slope is, and you can't tell what point it's going through. You'd have to do a little extra work to get to it. The good thing about general form is if you're dealing with two lines, it's better to write them both this way, rather than slope-intercept form. Now, does anybody remember what slope-intercept form is? Starts off with y equals mx plus b. What's m? Y. Really? In math, we just say it just is, and therefore it must be. So if I say you can divide by 0, you're all going to do it on your calculators, and then magically it's going to come up with answers now. Boy, I love the mental. We need to prove it. You can't just. I know most teachers in high school, they're like, m's the slope, b's the y-intercept, and that's it. Don't ask me any more questions. I'd rather, well, prove it to make sure you understand that it actually is the slope, and b is actually called the y-intercept for a reason. So, let's do the y-intercept first. How do you find the y-intercept of a graph? Now the y-intercept, if we go to this graph over here, I'm not sure if it's perfect, but it would be when it crosses the y-axis. Well, if you're this coordinate, let's say this is actually, is it really? No, it's not actually there. I drew my graph a little bad. Well, let's say that's the y-intercept. What's the coordinate of this point here? 0, -5. Coordinates never come in as a single number. It's always a pair. So it's 0, -5. So if you're a y-intercept, the only guarantee you have about it is the x-coordinate is 0. So if you're looking for a y-intercept, the only directions you get is let x equal 0. In your equation, just let x equal 0, solve for y. So you take y equals mx plus b. You replace the x with 0. 0 times anything is? 0 plus b is? B. And you get y equals b. So y is equal to b when x is equal to 0. So this is the coordinate, 0b. So b becomes the y-intercept. That's the reason it is. All right, how about slope? Well, how do you find the slope of anything? Literally, of anything, of a line. How do you find the slope of a line? Without an equation. What do you need? Well, how did I find this slope over here? I needed 2 points. I have a point. Yeah, there we go. 0b. It's definitely on the line. It's the y-intercept of this graph. All I need is another point. But it can't have a number value to it. It has to be kind of variable in type. So if I want to find the slope, I need 2 points. And we already have 1 from up there. So I just need 1 more point. So this is what we're going to do. Let x equal p. What can p be? Well, anything. Why? It's a variable. So I'm letting x equal another variable, but that p actually becomes a physical number eventually. So if I let x equal p, what does y equal? No. Y is equal to mx plus b. So if I let x equal p, y equals mp plus b, because I'm replacing x with p. So this becomes mp plus b. That's a coordinate. It's p, comma, mp plus b. So far, so good? So now I have 2 points. Point number 1, 0b. Point number 2, p, comma, mp plus b. Perfectly fine for variable relationship coordinates. How do I find the slope between those 2 points? Well, you do change in y over change in x. We'll go backwards. We'll go y2 minus y1. What's y2 in this case? That's an x coordinate, that's a y coordinate, that's an x coordinate, that's a y coordinate. So the y coordinate of the second point is the whole thing, mp plus b. So we go mp plus b, mp plus b, minus the other y coordinate, which is b, all divided by, well, x coordinate, p minus 0. Now simplify. This is where it gets cool. What happens to the b's? They cancel, so you're left with mp over p. What happens to the p's? They cancel. This is why m is the slope. Because I started on the left with change in y over change in x, which is slope. Did my algebra, and I ended up with m by itself. So this becomes 0b. And this number in front of the x becomes change in y over change in x. That's why slope-intercept form works really nice. Now do you understand? Now you can, when someone asks you again, you can say, I can prove it. Should I put that in the test? Wouldn't that be awesome? Nobody likes proving anything. Long lost art. As far as I can go today because we have the quiz. So, that's at least partial through 2-3. I'll finish the rest up on Wednesday. Alright, so we started, what was it, 2-3? And I got up through, I don't even remember what I got up through. Oh, y equals mx plus b. We proved that that was actually m is the slope and b was the y-intercept, right? So let's start there. 2-3, continue. Lines. So, equals mx plus b, where m equals change in y over change in x, and b becomes 0b as a coordinate. Now on a test, if I ask for what the heck the y-intercept is, if you tell me 5, I don't give you credit for it. Because 5 is not a point on a piece of graph paper. 5 is just a plain old number. So you have to say 0, 5 to really emphasize that you know it's on the y-axis and it's 5 units up. Alright, so that's what we were talking about last time. I think that's the last thing I did, right? Did I do slope-intercept form? Oh, well, that's what that is. Why is that supposed to be? Slope-intercept form. So my question is, can all stupid thing. Can all lines be represented as y equals mx plus b? Can all lines be represented by y equals mx plus b?
No.
What kind of lines cannot be?
Perpendicular.
Horizontal? It actually can represent a horizontal line. It's just that m would then be equal to, well, if you're flat line stock prices, is there any change? So it would be 0, and 0 times anything is 0, and all you get is b out of it. So yes, it can represent a horizontal line. Go the other way. Vertical. There's a problem with vertical lines. So let's talk about it. If we talk about horizontal, and the graph of a horizontal would look something like this. It's like a stock price that's going absolutely nowhere. As you move from left to right, you're not going up, you're not going down, you're staying basically like walking across this floor. You're not changing your distance off the sea level. You're not changing your distance off sea level. You're just going flat across. So this would have 0 slope. prove it pretty easily. If we pick 2 points on here, and let's say that this thing is 5 units high. So every point along this line is 5 units off the x-axis. Give me a reasonable coordinate for this one here. 2, 5? That would be over here.
Negative.
Oh, okay. Just you know your coordinate systems. I always do that. I don't give you coordinates, I make you give me coordinates. It forces you to think about where are we in the coordinate system. Over here, reasonable? 5, 5? Sure, why not? Alright, how do I find the slope? Well, you go change in y over change in x. What are the y coordinates for these points? Well, this one is 5 and this one is 5. So you get 5 minus 5 over. Then you go change in x, so you go to the x coordinates. Well, the x coordinate of that point is 5, and the x coordinate of this point is -2. Keep your focus on first coordinates or second coordinates, you know, x's or the y's, because I've seen people do x to y and y to x. Really bad. So 5 minus a -2. So this becomes 0 over whatever, 7 in this case. And the slope is 0. Means you're not going up, you're not going down, you're just flatlined. All right, what would be the equation of this line? Well, m would equal 0, right? What would b equal? What's the y-intercept here? Where does it cross the y-axis? At 5. So this thing actually has an equation of y equals 5. So y equals 5 has a slope of 0 and it's horizontal. Great. That still can be represented as y equals mx plus b, but I find it easier to say this. If I've given an equation as y equals 5 and I say graph it, you plot 5 on the y-axis and you draw a horizontal line through it. It is a line that only hits the y-axis at 5. It does not go up and does not go down. All right, the other type of line is, of course, vertical. So if I have a vertical line, it'll look something like this. It's going straight up and down. Now the problem with vertical lines is most graphs you have to, well, I should say all graphs you have to move from left to right, at least rectangular coordinate system ones. As I move left to right here, I'm neither going up nor down, or I have a positive slope or I have a negative slope. The problem with moving left to right on this graph is you have 2 choices. You either are going up or you're going down, but you can't do both of them. And since you don't know which way you're going, the slope on this one is undefined. A lot of books will say no slope. The problem with no slope is people equate no for some reason with 0. I don't know why. They don't even sound the same, and they definitely don't mean the same. 0! You know, so you don't want someone to stop. 0! No, no one says that. They say no. So I try to keep it separate. Slope of 0, undefined slope. You know, don't even use the word no slope because it just, it's not a good thing to use. All right, let me put 2 points on this thing. Put a point up here. Put a point down here. Give me a reasonable coordinate if this thing is 3 units away from the y-axis.
3, 5, 3, -3. -3, 5.
All right, this one down here.
-3, 3. -3.
Oh, give it a different number than -3, -3. How about -2? I hate repeat numbers because then you can't see which one's going where. All right, find the slope. So you go change in y over change in x, and we'll see why it's undefined. What's the change in y? Well, the top one is 5. The bottom one has a -2, so this would be 5 minus a -2 over
3 minus -3.
careful, -3 minus a -3. So the top is now 7 and the bottom is 0. But 7 divided by 0 is?
No solution.
It's undefined. No solution is also no real number associated with it. But it's better just to say undefined and be done with it. So that's why we call this an undefined slope, and horizontal lines are defined slope of 0. All right, what kind of equation would we give it? Well, I can't use y equals mx plus b because I can't plug in anything for m. I mean, at least for the 0 slope, I could plug in 0. So we're going to have to kind of do this with a little inference. This equation of a line, which was horizontal, is y equals 5. What's true about both of these points? What's the only thing in common? X equals -3. So the equation of this line is x equals -3. Hits the x-axis at -3, and it's a vertical line. Okay. So, for example, how would you graph x equals 2?
Two on the right side, straight line, vertical line.
All lines are straight.
Well, vertical line, up and down.
Up and down. So this would be x equals 2 as long as it goes through the coordinate 2 on the x-axis. Easy, right? How would you graph y equals -4?
Graph like or that -4 on the y-axis
Where is it?
on the bottom.
Up, down?
Yeah, -4.
I'm just making sure.
Should know that.
Devil's advocate. I know that. Hey, and then what?
Put a line right through.
What kind of line?
Horizontal.
Ah, horizontal. And that would be y equals -4. What's funny is those two cause more problems than it's imaginable. They're so simple that people forget to practice them or look at them. They're like, oh, I get it. And then I get lines that are all over the place. Also, I don't ask it so directly like that. I'll ask, give me an equation of line with certain properties, and they forget that there are horizontal and vertical types of equations that are really simplistic, and they try to make lines always look like this, and they don't always look like that. All right, so what if I have, let's go back to y equals mx plus b. How would you find the slope and intercept of this line? What's buried in this question is hidden directions. You have to understand what is it asking for. Well, it's asking for y equals mx plus b. Because from this form, you can find the slope and the intercept just by looking at it. Is that in y equals mx plus b form? So what's the hidden directions? Well, let's put it in mathematical terms. What am I going to do before I start moving things? What's the directions I would normally give you? Would I say move? What are you doing when you start moving things? What are you trying to do?
Make something myself.
So what is that called when you get something by itself? Oh, dear Lord. Begins with an S. Oh, solving an equation. So the hidden direction is we're going to solve for y, because we want to get y by itself. Isn't that funny? We've done all that really and move. Sound like a cow. Move. So what am I going to move? The 8x. To solve for this y, I need to move the 8x. So you get 7y is equal to 8x plus 21. Since I'm trying to get it into mx plus b form, I want that x term to be in this position. Another funny thing happens with people, but I'll talk about that in a second. All right, finish solving for y. Divide. The way I would do it is I would just divide everybody by 7. Instead of doing both entire sides, because you do the long fraction bar, you want to separate it as mx and then b. All right, so you get y equals 8 7's x, and put that x kind of by itself, plus 3. So when you get to the slope, don't write m equals, write this. Because this tells you what the heck is really going on. M tells you absolutely nothing. So the change in y over change in x is? Someone said it. They whispered it though.
8/7.
8/7. And the y-intercept as a coordinate is? That wasn't that hard, was it? And now you can graph it. Notice where I put my graph, all on the top. 8/7 is a positive slope, 3 is a positive y-intercept. Everything's going to go up. So, plot 0, 3. Here? Who said yeah? I'm playing devil's advocate. If you're a y-intercept, do you plot it on the x-axis? I have had more people plot a y-intercept right here than I can count. Make sure you look at it right. 0 left, right, 3 up. So it goes here. And then the slope says, change in y. 8. Which way do I go?
Why?
Who said
You.
Who?
Up.
Up. Change in y. Y-axis is up and down. So you go up 8 units. 1, 2, 3, 4, 5, 6, 7, 8. Someplace up here. All right, and then you're going to move over 7 units. So that brings me way over here. Wow, that's too big of a slope. Well, that's going off my board in that direction. Let's try the other direction. Instead of going up 8 and over 7, what's the other direction I can go? Down 8. 1, 2, 3, 4, 5, 6, 7, 8. Someplace down here. And then left 7, so someplace over here. And if I had a nice ruler, and you see what happens if you try to sketch a graph. If your marks are off just by a little bit, it throws your whole line off. So the only way to draw a perfect graph is 2 things. You need graph paper and a ruler. I love people that, ruler, credit card will do perfectly fine. Debit card, they have a nice straight edge on it. And my graph paper is only this big, so a credit card will work. So make sure your 3 points get hit by that line. They should be exactly on it. One of them is, like mine is, down here, way off. Either A, you graphed it really badly, or B, you plotted one of your points really badly. It's a good check place for graphing lines. What's the last thing I should do after graphing a line? Y'all forgot already. Compare the slopes. What kind of slope does this line have? Positive. What kind of slope did I start with? Positive. It's positive, it's 8/7. So they at least match up going the right direction. I gotta change this out. Now, I don't know about you. I went over by you. Crazy cat. I'll get it later. Alright. So that's graphing and y equals mx plus b form. Did y'all know this already? Yeah. Do you? It worries me. What if, for example, what if I had a line that looked like this? 5x minus 8y is equal to 4,000. Well, 4,000. 8x minus 5x minus 8y is equal to 4,000. All right, get it into y equals mx plus b form. What do I move? The 5x, so you get negative 8y is equal to negative 5x plus 4,000. All right, next step. Divide everybody by negative 8. And you get y equals 5/8 x positive minus 500. All right, get out your graph paper, plot the x-axis or the y-intercept, and graph this line for me. Come on. Don't you want to count down 500?
No.
Neither do I. So sometimes y equals mx plus b doesn't give you the best possible answer. So there's got to be a better way of doing this. And the better way of doing this is called graphing by intercepts. Oops. Graphing with intercepts. So if I draw a little baby graph here, and I draw a line through it, oops. It hits the y-axis there and it hits the x-axis there. Give me a reasonable coordinate for the x-intercept. That's this guy down here. X-intercept. What would be a reasonable coordinate of it? 3, 0. Give me a reasonable coordinate, and please don't use 3, for the y-intercept. 0, 2. All right. So when you say x-intercept, the only thing you know about an x-intercept is one thing. That 3 can change depending on where I put the point. The only thing that stays the same is y is always equal to 0. And conversely, the y-intercept, the number is going to change in the y position to wherever you are on the y-axis, but the first coordinate has to be 0. So when you're graphing with intercepts, to find an x-intercept, you're going to let y equals 0. And then to find a y-intercept, you're going to let x equal 0. And by the way, this doesn't just apply to lines. This applies to all graphing. Graphing any weird-looking equation going. If you want to find x and y intercepts, that's how you do it. All right, so you go back to your original equation, and you say, well, if I'm trying to find the x-intercept of the original equation, I just take y and let it equal 0. So I get 5x minus 8 times 0 is equal to 4 grand. And 8 times 0, of course, is 0, and that just goes away. You get 5x is equal to 4,000, and x equals 800. So that'd be 800. Do the same thing for a y-intercept. Separately, don't use the same equation as that. Go back to the original. For a y-intercept, you're going to let x equal 0, so you're going to get 5 times something minus 8y is equal to 4 grand. The something happens to be, well, 0. 5 times 0 is? Goes away, so you get negative 8y is equal to 4,000. We already knew this answer. Y is equal to negative 500. From up here, we knew the y-intercept was negative 500. All right, so what coordinate is the x-intercept as a point?
I mean, 800 0.
The x-coordinate is 800. The y-coordinate was chosen to be 0. What's the coordinate for the y-intercept?
0.
Negative 500. Okay. Now we can plot this on a general graph. In other words, we're not going to hash mark it to death. You're just going to plot points and then see what's going on. So 0, negative 500 is someplace down here. So you put a point here and you label it negative 500. It's way down someplace. And then the other one is 800, 0, so he's over here someplace. That's 800, 0, why not? This is 0, negative 500. And you draw your line. What kind of slope does that line have? Positive, just looking at it. So sometimes when the numbers get big, you just want to get a generalized picture, not a very specific one. Intercepts are very good for that. But they're also very good for graphing other things. Much more complex. Talk about this. Draw a little picture here. This is going to be very generalized. Here's a point. Let's call its coordinate x1, x1, y1. So I give you a point, and I say a line is going to go through this point, but it's going to have a specific slope. Let's say it has a slope of change in y over change in x. So I go up and I go over according to change in y, change in x. At the end of the change in y and change in x, I generate another point. Now, how many of these points exist that have a ratio of change in y over change in x? Just the one? How many? A lot. In math, when you say a lot, infinite. There's an infinite number of points. Now, the cool thing is, my slope could have been 2/3. I could go up 2 and over 3, right? I could also go up 4/6. Go up 4 and over 6. That would still have a slope of 2/3, right? I could also go up 1 over 1.5. What did I do to my slope? Cut it in half, top and bottom. So either you multiply top and bottom by the same number, or you divide top and bottom by the same number, and the slope does not change. So that generates all the points in between these 2 points. I can make the change in y over change in x really, really small, and then just gradually grow it so it fills in all the points. Well, since it's going to generate an infinite number of points with change in y, change in x ratio, this one is going to be represented by variables, where x and y are all the points that lie in the line that starts at x1, y1, and has a slope of change in y over change in x. Does that make sense? I'm not talking about x, y being any point in the coordinate system. It's a very narrow field. It has to be all the points on that line. So x, y is any point on that line. All right. This is probably the only time I use the slope formula as the book gives it. So you start off with, well, change in y over change in x is equal to y2 minus y1 over x2 minus x1. And then I just want to make one more adjustment. Let's get it down to one variable. Let the slope equal m. Let the slope equal m. So if I do that substitution, where does y2 come from? Well, it comes from this point. But this y is just plain old y. So first off, change in y over change in x becomes m. Y sub 2 just becomes y. Y sub 1 is itself, so leave him alone. What's x sub 2 become? It just becomes this x here, which is all the possible x's on that line. So x minus x sub 1, the other point, way down here, x sub 1. So we get this little setup, where x and y are variables, x sub 1 and y sub 1 are physical points, or a physical point, and m is the slope. What don't you like about that equation? It's boring, right? I'll feel like that later. What's that?
No, because you can manipulate.
Yeah, but what do we not like about that fraction? Ah, I just said it, darn it. That equation. It's got a fraction in it. How do you get rid of fractions? Multiply by the denominator. So I'm going to multiply both sides by x minus x sub 1. And I'm going to kind of change the order of things. So y minus y sub 1 equals m times x minus x sub 1. This is the point slope form. I know, isn't that great? The point slope form of the line. Where y equals mx plus b is really good for graphing a line, point slope form is really good for find the equation of a line. Just give it a point, give it a slope, throw it in, generate an equation of a line. Done. So for instance, the way I define a line is the shortest distance between any 2 points that goes off to infinity. Another way of defining a line is going through a certain point with a certain slope. And the slope never ever changes. Other graphs, they change. Lines, they never ever change. Constant slope, constant slope. So how do I find the equation of a line that goes through 2 points? Well, the hint is in the equation that I just gave you. You need a point, and you need a slope. But I gave you 2 points. So you need to generate slope. So how do I find slope? So you do change in y over change in x. So that equals, I know you're going to go backwards, so you might as well do it.
7 minus -2.
Now you went forward. 7 minus a -2. Over.
4 minus 5.
Careful. -4 minus 5. Which equals, I didn't plan on this. 9 over -9. Oh, that's boring. -1. I was hoping for some ugly slope. That's what you get for randomly choosing numbers. Alright, so now I have a slope. Does it matter which point I pick? No, because they're both on the line. So whether I run the slope from 5, 2 of -1, eventually it's going to run into -4, 7. If I start at -4, 7, it's eventually going to run into 5, -2. So the next step, of course, is your formula. Oh, by the way, you need to memorize this. Another one. For the next test, of course, you quadratic formula, all that fun stuff, completing the square, solving equations. But for this one, this is the first formula you need to memorize besides slope. And I figure you don't have to memorize y equals mx plus b. All right, what do I plug in? Well, you go y minus, which point am I using? Pick one. 5, -2. So we're going to use this point, and this is our slope. So it becomes y minus a -2, so that turns into +2, equals m, -1, x minus x minus 5. Don't say x minus -5, because then it'll be x plus 5. So x minus 5. Alright. Distribute the negative, so you get y plus 2 is equal to -x plus 5. Now here's where me and the book will get a little different. The book wants it in standard form. X and y on the same side, numbers on the opposite side. So if you want to get x and y on the same side, move the x over, so you get x plus y. And it's going to equal, subtract the 2, 3. So this would be the book form. So when you go to the back of the book, that's the equation they're going to have for your answer. If you don't like the book form, you can always take the book form, solve it for y, and come up with the form I'd rather have, which is solve for y. So if you solve for y, just move the 2 across and you get y equals -x plus 3. And that's what I'd be looking for. So if you write it either way, I'm perfectly fine with it. I prefer you to write it this way because right from this form you can graph it. Of course, you could just graph the 2 points and draw a line through it. That'd be the easiest way to do it. This form doesn't have a lot of uses until you get to systems of equations. Standard form. That's not that hard, right? Pretty easy.